Hi there, welcome to Cloud Native Skunkworks. Today is about how to unterminate Kubernetes resources. I think we've all been there when we've been practicing, whether it's in production or whether it is just toying around, and we've ended up deleting something we didn't mean to. Most typically, that will be gone within an instant. However, there are some chances when you see terminating hanging tentatively in the status field for your resource. This is where you have an opportunity to reverse the course of history and to undelete that object. Typically speaking, this would be something like the following. You would have a pod with a PVC. Now the PVC won't terminate whilst the pod is still running because the PVC will be bound. Specifically, I would like to cover a scenario where you might have data loss if this PVC was lost. And so we have to do everything we can to try and save that PVC. However, the effects that we're going to look at today and the strategy can be used with other resource types too. So I've created a very simple repository here, as you can see on my screen. This is called Unterminate, and the project is very basic. It has Cobra. Cobra is a CLI tool for Go. I won't go through Cobra, but what I will do is show you that I've built effectively one command called pvc.go. It doesn't do anything just yet, but it will do eventually. What you also see is that I've got a couple of examples. In the example, I have create a persistent volume claim and create a pod. So I have a bare bones kind cluster set up, and there's not much going on in this cluster right now. So let's install what we need to install. It's got the local path provisioner, so let's get Nginx example with its PVC up and running. So this is pulling the image. It's also provisioning the PVC, and this is great because we can start to replicate the behavior that we see in this tutorial. So one problem is that out of the box, the kind cluster does not have the correct local path provisioner storage class. So I'm just going to grab that. Luckily, I anticipated this, and I have a handy link in the repository. So you can go and just grab the entire deployment again, and it will install it correctly. And you can see now the storage class has been created, and we can provision the cluster. And now what's cool is that you've got the pod being created, but you'll notice that we actually have a second container that's being created and destroying the first for the local path provisioner, which is all good. It's not important for us. So like I mentioned a moment ago, we have the PVC in a bound state, and I'll just emphasize this by putting my screen size up a few notches. So you can see there it's bound, and we should get to the point also where the pod gets to running. When that pod gets to running, when Nginx has been pulled, what we'll do to simulate this kind of issue is we will delete the PVC. Also here you can see another opportunity just there was the local path provisioner was terminating. There might be a chance for you to rescue pods that are terminating depending on the finalizers and the conditions of their termination. So right here, you can see I've got a bit of a README I started building, but effectively, we've got nothing else in this function. The first thing we need to do is the setup. In the setup for this project, we need to have the etcd certificates that we're going to use. We need to have a way of talking to etcd, so that might be a port forward, and we need to have some basic tooling installed. So let's get this pod into a terminating state. So there we go, deleting pod, nightmare scenario. Worst thing that could happen, what do? That's data loss. Customers could potentially be screaming down the phone or over email or over WhatsApp or probably on Twitter about what's going on here. Okay, we're going to build a rescue plan here. So what we need to do is to figure out how do we change the status of this in etcd. And to really understand that, we need to understand a little bit more about the background of how Kubernetes works. And effectively, kube control is an interface to etcd, and everything you do in Kubernetes is going to be key value storage. So you have a registry field, and inside the registry field you have persistent volume claims. The registry is for the different types that are stored as resources within the cluster. Those volume claims will then usually split, I believe, by namespace and then ID. And I might have this wrong, but we'll check together in a moment. But what happens is that object for the PVC lives inside of Kubernetes etcd. However, I cannot modify things as a user outside of here. For example, I cannot take away the deletion timestamp. The deletion timestamp is what actually quantifies it being a terminating state as according to the controller manager. So if we could release that deletion timestamp, we could effectively rewind history and put this persistent volume claim back into a healthy state. So what the objective today is going to be to effectively write a program that can talk to the etcd control plane. I mentioned the etcd control plane a moment ago in terms of certificates because that's the hurdle we need to get past first, is that etcd control plane requires authentication, and those certificates usually are going to be mounted. And what we will do outside of cluster is port forward using those certificates that we'll download and mount within our program. So we'll call it unterminate. And what unterminate will do is it will talk to etcd, and etcd will in turn will update its opinion on what's happening with this PVC, and it'll make it good again. So what do we need to do next? Okay, so we've got the terminating PVC. We don't have the etcd certs. Etcd pod that you get in kind and in most Kubernetes clusters has an extremely limited set of commands you can run. You can't less, you can't cat, you can't do anything really. So you can't even kube control copy actually, because there's no tar function, and tar is used to compress the data as it comes down the wire. So really the best way to do this for the kind cluster would be to go to the Docker level. So from Docker, in fact, let's go back up a step. I need to understand the path I need to copy firstly. From etcd-ctl, so etcd pod rather, let's have a look at the volumes. So it's going to be host path etcd Kubernetes, etc Kubernetes pki etcd. So Docker copy deb7df53bda4, and then we're going to copy that into etcd. So now we have our etcd certificates, and that's wonderful. So what we can also do is a quick command to, I think I had this previously, maybe not. We're going to run a quick command just to check that things are running okay. I've saved it in the README because this is one of those gotcha commands that's always a hassle to type out. And here it is. You can see I did a little bit of this setup just to make sure it was working correctly. So and we go now etcd server key / server.cert member list. The key thing I haven't done yet is to port forward. So let's now port forward. Okay, so etcd control plane. Now it doesn't offer you container port, but it's 2379. Let's go up into our project. And let's run that command again. This is primarily because I think I've copied it into the wrong place, which was my mistake. So let's put the Docker copy into the folder. Now you can see etcd with all the lovely certificates showing up. Let's try it now. Cool. We can see we've got a single etcd node, the kind control plane. Brilliant. That also means that we now have access to use etcd, and we can start to explore what it looks like. And now you'll notice that I've used the etcd version 3 API, which does differ to the previous API. And there used to be an ls command, and I think now it's a bit different. It's now get and then prefix /. So now we can see the registry. If we go keys only, I believe. I might have to check this. Keys dash keys only equals true. Keys only. So now you can see all of the resources in Kubernetes in the registry, and the one that we care about fixing is our persistent volume claim. And let's try and find it. So if I go persistent, there we go. Here's our claim. So let's try and open our claim up and see what's going on. So if I go like this, here. Now, first thing to note, this is not YAML. This is encoded. And this is something that we are going to have to overcome, because this encoded data cannot be pulled out, used, and then injected again. So we're going to have to write a solution to this using the runtime protobuf decoder. But here it is, here's our data. And what we need to do is scrub out one of the fields when we get there. So now we know where our data is, what we need to change. Let's go write some code. So the first things that we need to do are to decide, what the heck are the certificates, what are the things that we actually need in this PVC command. So this might be a bit boring, and I'll save us some time by trying to do it really quickly. So let's go ahead. PVC command dot, we want to flags dot string rp, and we're going to go etcd ca etcd ca c nil etcd ca. And what I'll do is I'll go ahead and create all those vars that we need, string, and then we've got etcd cert, etcd key, etcd host string, but for us it'll just be 127, etcd port string. We can make those last ones optional for this video. So let's go ahead and grab this stuff. So etcd cert, etcd key, etcd host, and we'll do etcd port. And believe it or not, this is usually the most hard bit to get right, because you'll end up making mistakes. Etcd host, etcd key, etcd cert. Interestingly enough, you have to make these unique, otherwise you'll get a crash and you will not know where it came from. And H, unless you've worked with Cobra before. Okay, so there we go. Let's just try all this out. What I want to do is I want to get to my function, and I want to make sure that these are all being assigned. So let's just start this out and say print line, printf, say etcd. Yeah, perfect. This is a little bit of an example of where Copilot can save you a little bit of time, as you see there. It's not always super useful. So anyway, we'll print out, in fact it's gone multi-line, and it would have been more useful to do single line. CA, etcd key, etcd cert. Okay, so we've got CA, etcd key, etcd cert. And let's just set that up so that we've got all of the correct stuff plumbing into our library. I'm using VS Code, so I provide it as an argument. I've called PVC, PVC is the name of my command. So etcd ca is the next arg, and that's going to be etcd /ca dot cert. Then it's going to be -- etcd key, etcd server dot key -- etcd where are we? Is it server cert? I think it is. I can't remember. Brain is like a sieve sometimes. CA cert and key. CA cert and key. CA cert and key. Cool. Okay. Okay. Let's just double check by running this. So I will go ahead and figure out where my menu bar has gone, firstly. There we go. Sneaky macOS trying to be helpful. So let's give that a go. Yeah, so this is usually an issue where you have a flag already set. So let's just have a quick check. Oh, okay, because I have, let's just change these. Okie dokie, that's one thing that needed to be fixed. Let's see what else there is. Okay, redefine help in PVC flag, it's already used, that's fine. Where are we defining help? So PVC command, here we go. That's already a global So we'll call that O instead. Hopefully that doesn't explode. Okay, so there you see we've got our files correctly being printed. That's the step 0 of this adventure. So the next thing we need to do is to think about, well, we need an etcd client. So for this, I actually went and used etcd client v3. And the v3 client is important because that's also the version my cluster is running at. So you can see here, I can just go ahead and import this client. In fact, I've already got an import, so I'll just grab that bit. And what I want to do is to create some sort of primer function to create my client. So func etcd client, well, that's cool, isn't it? Client error, and then it's going to suggest how that should build. So CA error. So first thing we need to do is to load in the X509s. So we go ioutil.read file, read file, and then we'll call that etcdca. And if error is not equal to nil, we'll return nil and error. We also need to, at this point, include ioutil, which is great. ioutil is io/util, I think. Okay, that's right. And then from here, we need to do what I was saying a moment ago, which is to load that key pair in. And this is actually really straightforward to do. It's just a bit of muscle memory. So key pair you get from doing tls.load x509, and that's going to be the etcd cert, and then the etcd key. We'll take this. Okay. From here, I think I've got everything loaded in. So TLS has been imported already, which is great. And then our cert pool is going to be x509 cert pool. And then we're going to add our CA into that cert pool. Add append. That's right. Okay. So X509 we need to import. That's come in. Great. This is looking good. So at this point in time, we need to think about what are the next steps. Well, at this point, we want to actually create the new client. So let's go return client v3.new. I think that's just going to be wrapped in a client config and a nil error. Right, okay. Let's see how that feels. Okay, so let's see. It says 2 values, single value is expected. Okay, this is because the client v3 new is returning client and error, which is not a problem. What we'll do is we'll say client error. If error is equal to nil, return nil error. Return client error nil. Cool. Now the important stuff we can do, and I mentioned about the host, we don't have to give it the host endpoint, but as you can see here, we can pass that in. We can also actually, to save ourselves some pain, to set the host automatically to be localhost and the default port to be 2379. And that's great. So we've got now the high level of the client. Oh, of course, we have to put a few other things like TLS. That's going to be TLS config. And in our TLS config, we can use our root CA, and that's our cert pool. We can also use the certificates, which is finally where we get to use our key pair. And insecure skip true. Okay, I'm missing a semicolon somewhere. So that is here, I think, at the end. Let's have a look what's going on. Oh, I think I need to go closing brace like that. Cool. So that's our etcd client, which is pretty straightforward. Okay. So now we've got that, we want to be able to do something else. We want to be able to actually spin up that client. So let's try that. So client, if nil. Okay. So that's our client. And we could do something with that client. We could do a get, but we're not going to do that just yet. We're just going to play around with actually building out some of the structure for what we need. And in fact, we could actually just have a look at it. Let's just go response error client.get context.background, and we want to get, what was it, registry. Let me just find it. Persistent volume claims. That's a persistent volume. Let's go back to check our volume claims. Okay, persistent, it's all one word. Okay, there we go. Okay, so now we've done that, we can say that this is what we care about. Go get all this stuff. And from that, I should put an error message. So if, okay, so let's put an error message in there. If we can't get that stuff, then, you know, that's not good. But let's go for raw KV. So at this point, let's just print the value. So that's our objective today. So let's try that. Now, this probably won't work because I don't have my port forward. Oh, apparently I do. So you can see now I've got data coming out of the persistent volume claim in etcd, which is great. So what do I do now? Well, this is where we need to start thinking about how do we make Kubernetes work with this. So we need to grab the resource, and we need to do that in code. And to do that in code, we need the schema imported. So we need to go to the runtime schemas. That's Kate's API machinery, package, runtime schema. I think something like that. Full disclosure, I did actually download these modules, so they should be here somewhere to make it a bit quicker. So let's go figure out what we need. We effectively need the group, we need the version, and we need the kind. So let's go g version and kind, group version kind, and the group is going to be v1.groupName, and the version is going to be v1 version, and the kind is going to be persistent. Now this is important because we are going to do a little bit of gymnastics in a moment with the data itself. I also need to have these types defined, so that's Kate's.io, I think. API core v1. I might have to look this up. I think that's right. Yes, that's the core version API. Good. Okay, let's just try that again. I think that probably is not going to accept that type. Let's just call it v1. Okay, and then this is where it gets interesting. So at this point in time, we have this ability to use anything from the v1 library. So I can say PVC, system volume claim. Should work. Yep, so now that's a new volume claim. And what I want to do is to copy the data into that. Now, as discussed, this volume claim is encoded. And so what we need to do is to implement the runtime decoder to use the, well, it's like a wrapped version of protobuf that comes with the serializer. So that's going to be Kates.io, API machinery, package, runtime, serializer, protobuf. Okay, so now we've got that, and this might seem like a super random thing to import, but there's some reason behind why you need these semantics. So we're going to say, we've got a new runtime schema. In fact, I'm going to define that actually outside of my loop. So runtime schema, runtime.scheme, cool. And from that runtime scheme, it's scary how this can fill this in so quickly. Here though, instead I want to use my, okay, and also is that runtime not implemented? Let's check. Okay, maybe I got this wrong. Let's try getting that package. Okay, let's have a look. If I go to my terminal and go get, okay, so Kate's API machine, oh, I put an A in machinery. Okay, that would help. If I spell it correctly, that would definitely help. Okay. Okay, that's happy. Let's just see if this is an issue with the IDE perhaps. I'll just do a run, see what's coming out. Okay, undefined runtime.new schema in, okay. Before I worry too much, just got to make sure that where okay, so I've got runtime here defined. That's not what I want. It looks like there's a collision. Let's have a look at that again. And in fact, if I grab this, do a modification there, I don't just want this one, I also want runtime from here. That's what I want. Okay, so let's have a look. What else is? Cannot use this argument. That is because the schema group kind version might be wrong. Let's have a look. Add known types to schema group type. Okay, add known types. That's interesting. What I will do, and this is a gotcha that I mentioned in a previous video, which is you need to put replace directives for anything involving Kubernetes. I'll just grab my operator code and grab the go mod replace directives, because this is a collision. Okay, so let's grab this and we'll do a replace. Okay, go mod tidy. Looking a bit different already. And let's now double check and see, are we on the same page? Add known types, which I'll do now. Known types. Let's have a look at that. Screen version. Okay, interesting. So it has a schema group version in type. So let me have a think about this. That argument is wrong. It's asking for something different than what I'm providing it. I think I've just used the wrong method. Yeah, that was it. Okay. So now we've got our schema. We now need to create a runtime serializer. So proto serializer, protobuf, which I did import, new serializer, runtime schema, oops, and that is not required. Okay, let's grab that. We'll go protobuf, and this is a particular version of protobuf. Okay, let me just make sure that's imported as well. Oh, I'm sorry, that goes inside of serializer. Protobuf. Okay, cool. So now we have a way of serializing that data, which is very exciting, and deserializing it. So what we want to do here is we want to decode it. So proto-serializer.decode raw KV value into a at the group kind PVC. That's our decoding operation. So we've now got the return type of runtime object, schema group kind, and error. So actually, all we care about at this point is the error, because we're decoding into our object, actually, which I should have defined here, and we should be doing that like this. Wonderful. In fact, this should probably be defined like that. Okay, now let's put errors in. Errors not to nil. Let's print the error, return, and exit out, which is great. So now, if I put a breakpoint here, we should have a fully fledged persistent volume claim at this point. Okay, let's have a look. This might be a little bit small for you to see, but what if I look at this? As I can see, I have a persistent volume claim, and I'll just increase my screen size. So you can see there is my PV task claim as a persistent volume from the object meta. Wonderful. Okay. So now we have our persistent volume claim. What the heck do we do next? Let me just make sure my screen size is readable. There we go. I think that's where we were. So let me stop the program. The next thing we need to do is to make the adjustment on the volume and save that data again. So let's have a look at what we need to do. So what I want to go for is to set the object deletion timestamp to nil. So I will I'll dereference the object PVC dot object meta, not resource version, deletion timestamp equals nil. I'll set that to nil, and that should be. And then I also perhaps want to set the PVC dot object meta dot deletion grace period to nil as well. Okay, so that's that bit done. Now we want to recode that data. So that is going to be protobuf proto-serializer dot encode PVC into first thing is I now need to have an output, and that's going to be a bytes buffer. So var fixed PVC bytes dot buffer, I think, fixed PVC. Perfect. So now that's ready to go back into etcd. Let's grab this. Now from this point, it's pretty straightforward actually, because all I need to do is a client.put on the context background, fixed PVC. Now the trick here is where it goes in its name. Its name should be here. So we're going to call it format.printString, sprintf, and we're going to go registry persistent volume claims / interpolate those, and we'll take the values of the namespace and the name straight out of the PVC itself. So I'm hoping that in a big reveal we can run this code now and we will fix our cluster. So let's have a look. So here goes nothing. And voila, we've repaired our persistent volume claim. I hope you've enjoyed this video. As you can see, it was live coding. I hope that it made sense. I will be posting this code up on CN Skunkworks GitHub. As ever, please do ask questions if anything wasn't clear. I'm happy to make addendums. I'm happy to go into other things in your comments. I really hope you like the content. I hope you found it useful, and that can give you ideas how to actually unterminate other resources as well. As ever, if you like my channel, if you like the stuff I'm doing, please do like and subscribe and comment. It means a lot to me, and I hope to see you in the next video. Thanks again.